And if you take the selling cost minus your costs, or the selling price minus your costs, then that's your revenue or your profit. Okay, let's look at transformations of graphs. Okay. What kind of an equation do we have here? We have a quadratic equation, a second degree one. So what that means then is we're going to have a U shape always. You can see my graph that I drew over there for this equation. Okay. Actually, this equation right here is that equation. This one would have one variation. What's the difference in the equation over there and the equation here? It has this 3 added. So what you would end up with then is that would move this up to 3 places, and then everything would move up like so. In other words, it's the same shape, except it's just shifted up 3 places is what that 3 does for you. Now you can see this. How did I get this? I just picked some x values because x is our independent variable. So we picked these. Y is the dependent variable. The y values depend on the rule, the equation. So if x is 0, y is 3. You can see my blue point there. If x is 1, y is 4. If x is 1, y is 1, 2, 3, 4. If x is 2, 1, 2, then y is 7. Now, we did some negative ones too. Because this is a square, you have to do the negative side also. If x is -1 right here, then it's 1, 2, 3, 4. And if it's -2, it'll be -7. Right? I drew this a little too wide here. Should have come through this point here and on up, and so on. So you can graph these by point plotting, or you can graph them by knowledge. Now, I have a handout for you I need to show you. This handout's kind of towards the back of your packet. And it's this sheet right here. Hopefully you can see what that sheet is. Okay, it says up here, graphs of basic functions. Shows you a line graph in the basic equation. Y equal mx plus b. Y equal to x, diagonal line. A quadratic, which I have on the board. A cubic, a square, absolute value, which is always a v, a square root, which is kind of an arch pointing out. Cube root has on both sides of this, whereas square root just has on this positive side. 1 over x always has these 2 sides like that, and so on. You pretty much need to learn to recognize those graph types for our coming assignments. Well, their graph's a little prettier than mine, but not much different. Okay, here we go. Now, the equation y equals square root of x plus 3. Over here, I have graphed y equals just square root of 1 with no add-on. Okay? Now, here's a little trick. If there's a number added to the x inside of parentheses or under a radical, it will move the graph opposite of sign that far left or right. Okay, opposite of sign. If there is a number out here outside of parentheses or radical, then it moves it up or down. Well, here is just calculating the points. If you let x equal -3, you get a 0 in here. Square root of 0 is 0. If you let x equal a -2, then you would get a square root of 1, which is 1. If you put a -1 in there, you get that, which if you look up on your calculator is 1.414, and it's a number that just keeps on going like the values of pi. If we put a 0 in there, then we get square root of 3, 1.713, and so on. If we put a positive 1, we get the square root of 4, which is 2. We put a positive 2, we get the square root of 5, which is 2.232, and it keeps on going. Okay? For graphing, about 1 decimal point's all that we can even remotely accurately graph. Now let's put that graph on top of this other one. Now let's see what happened. I told you that if it's underneath the radical or inside the parentheses with the x, that it'll move it left or right, opposite of sign. So this should move the graph 3 places left, or in the negative direction. Here was my y equals square root of x, 1, 2, 3 places to the left, and everything follows. Okay? And what are these things called when you have these shifts? They're called transformations. Okay, slides, rotations, flips, those are transformations. Okay, now what I'm putting on the board now is similar to what's on that handout I gave you. Recognize basic functions. A linear function, or linear means straight line, y equal mx plus b. They're just using function notation instead of the y. Okay, y equals b. That just means it's a horizontal line. We're missing the x. So all you've got is the vertical height. Okay, y equals x. That means it goes up 1 over 1, up 1 over 1, up 1 over 1. This is the fundamental y equal x equation for linear equations, or the identity equation, sometimes it's called, and it goes at a perfect 45-degree angle. Okay, a second degree equation, y equals x squared. Going to be a quadratic. If there are no modifiers, either in a parentheses with the x squared or behind it, then it'll be here at 0, 0 and go up on each side. Okay, let me pull this down just a little bit more. Okay, y equal x cubed. Okay, in this case, we get an equation that looks like this. starts down at the left, ends up at the right. Okay? And if we did a XY table on this one, if we let 0 be X, okay, then Y would still be 0. If we let X equals 1, okay, then 1 cubed is 1. If we let X be -1, -1 cubed is -1. If we let X equal 2, 2, 4, 8. Okay, X is 2. 1, 2, 3, 4, 5, 6, 7, 8 up here. And likewise, if we let X equal -2, it's going to be -8. Okay, now this is just the basic function. Modifiers will stretch or squeeze or narrow or do things like that to this graph. But this is just the fundamental one. Oh, didn't erase my points. Okay, more basic functions. Here's the square root of X. I had the graph of this over here. Okay, notice this 1, 1 point and 0, 0, 1, 1, and it goes on. Cube root of X. Now, see the cube root of X? Look at X cubed. Okay. In other words, the other one started off like this and went up like that. These two are at a 90-degree angle to each other. They are a reflection of each other. These 2 points reflect, those two reflect, these two reflect, those two reflect, these two reflect. Likewise over here, this is square root of X. And this would be X squared. Okay. Now, there's a hidden half of this one. Okay. Notice these two are at right angles to each other. The hidden part of this one is because you can't have negative square roots. And that's why that happened. Yeah, I shouldn't have marked on my duct tape. Now it won't clean up good. By the way, those are called inverses. We'll talk more about that later. Absolute value of X always makes a V. You see a graph of a V, it's an absolute value. If I had absolute value of X minus 1, then f of X equals, or Y equals, then that would move this to the right one place and would go up like this. In other words, it would shift at one place opposite of sign. Okay? If I had this one, then that would shift it to the left, the negative direction, 2 places. 1, 2, and so on. And those are transformations. But if you know these fundamental shapes that I've been going over just now, then you'll be able to graph a lot of problems without having to do point plots. Okay, here's the 1 over x one. It's going to characteristically have these. Now, this can approach there, but it will never quite touch it. Same way here. It can touch the x-axis, but it can never touch this vertical axis on this particular problem. And this will be the place where we're going to stop for today. Hope, given all my blunders that I had earlier, that you were able to ultimately figure out what we're trying to do. We're going to talk some more about horizontal and vertical shifts, vertical shrinking, things like that tomorrow. Have a good day.